This video is going to cover the topic of random sampling. Be sure the date and topic are at the top of your page. The essential question for our video will be, how do we ensure that our statistical sample is random and representative of a population? As we know from our previous work, when we want to collect statistical data, sometimes we can get the information from a whole population, but other times, for logistical reasons, we need to use a sample. And of course, a sample is when we use a smaller group or a subset that is chosen to represent the whole group. A sample, the idea behind it is that we can infer information about a population without having to get the entire data from, say, every person in the United States, if that was our population. Since that is the case, we must therefore ensure that whatever sample group we choose is a reasonable representation of that entire group or population. Which brings us to what we call a random sample. When we think about creating a random sample, there are a couple things that we keep in mind and some goals that we have. One is that every member or every part of the whole group has the same chance of being chosen for that sample. The other is that the size of your sample is proportional to the whole group. And the goal here is that we want to make sure that the sample group does not have any bias or will produce any skewed results. Let's think about collecting data on the number of times students at our school rode their bike last week. So we probably can't ask everybody at school, so we'll need to choose a sample. One option might be that we could go out to the bike rack and interview students as they are leaving school for the day, right? We could ask them how many times they rode their bike last week. I would not consider this to be a good sample group, a good random sampling of the students, because most students who are hanging out near the bike rack are riders. That would skew my data because I would be getting my data disproportionately from students who ride bikes. That would not work. Maybe a second option could be to make a sample group of the 50 students that I see during the day, right? Out of 600 or so people, maybe if I find 50 to 100 people to ask, I could just ask them how many times they rode their bike. Well, if I'm conducting this interview and I just do the kind of students that I see during the day, if I'm a student myself, I probably end up seeing my friends. And my friends and I have probably some things in common. And if I ride a bike, they might also be bike riders. We might be friends because we ride to school together. So again, this would create some skewed data. Option number 3 would maybe I get some help from the folks at the school office, and they could generate 100 names off a list of all the students at the school, and it would be just a random computer-generated list that I could then find those people with those names and get their answers to my questions. This is the one that I like, right? This is the one where all students have an equal chance of being in the sample group. It's basically like putting everyone's name in a hat and picking some names out. So I'm going to write down some examples of samples, and we're going to see if they are random or not. So in our first example, I'm not going to tell you what it is we're researching, but we're just going to look at some populations. So if the population is all the students in the school, would the sample group of just asking every 5th student you see in the hall outside class be random? And we're just going to say whether we think it is or is not, so think for yourself first. And in this case, I would say this is not random. And it wouldn't be random because you don't have an equal chance of being chosen, right? Not everyone's in the hall at the same time. And maybe if we're in the hall where 6th graders have class, 7th and 8th graders probably aren't walking through, so they're unlikely to be part of the sample. It would not be a good random sample. What if we wanted a sample group out of the population of all the students just in your class? Would a good random sample be one where students have the letter F in their name? Think about that for a second. Think if that's random, yes or no, and then we'll see if we agree. And again, on this one, I would say no, that is not a good random sample. This one might feel like it's kind of random because you're maybe randomly picking a letter, but it's not, because students without that F in their name would not have the same equal chance of being a part of that population's sample group. So this would not be a good random sample. This example is still with a population of all the students in your class, but this time the sample is done by students all putting their names in a hat, and we draw the sample group by drawing names out of the hat. Would this be a good random sample? Yes or no? This time I would say yes, this is a good random sample. Because this time everyone has the same opportunity to be a member of the sample group. A population could be that you're trying to get data on all the people in your neighborhood, and maybe a sample you consider is the people who are outside playing at 6 o'clock when you go out to collect data. Would that be random, to just ask anybody who's out on the street while you're out at 6 o'clock? And once again, I would say that is a big no, not a good random sample. That would only have the people who are out after 6 o'clock included in your survey, included in your research. And that could be very skewed, right? Maybe the survey is about who wants more lights outside in the neighborhood so they can play outside. Those people are going to have a different opinion, perhaps, than people who don't go outside. And here's one last example. If the population is that you're trying to get data on everybody in the room and you want a sample, and everybody tosses a coin in the room and those who land on tails are the sample, is that a good random sample? And I would say definitely yes. And after all, right, flipping a coin, getting a heads or tails is equally likely. So if everyone does that, everybody's participating, everyone has an equal chance of getting a tails, which means they are participating. So it would be a nice random sample, a creative one, a nice random sample. And remember that the essential question for this video was quite simply, how do we ensure that our sample is random and representative? It sounds like a simple thing, but sometimes you'll come across data that's been collected in a not so random way. We want to make sure that we prevent that from having skewed or biased results. So we'll be working more on this in class. Be sure to have your notes with you.